I'm going to run you through a quick refresher on using PEGS. So in this problem, it says, when Aroldis Chapman set the record for the fastest baseball pitch, he gave the baseball 162.9 joules of energy. If a baseball has a mass of 0.145 kilograms, how fast did Chapman throw it? The first step is always to identify your unknown. You look for words like how, which in this case it says, how fast? So when it says how fast, that means I'm looking for speed. And remember, you want to use the same letters that show up in the formulas. We use a V to represent speed in the formulas, so I put V equals question mark. The next step is to identify my givens. We've got 0.145 kilograms. I know that's a mass, partly because mass is always in kilograms, and partly because we have that wording, a mass of 0.145. Again, when I'm listing it in the space for my givens, I want to make sure to use the letter from the formula, which is an M. The other given is this 162.9 joules. This one's a little bit tricky because work, kinetic energy, and potential energy are all measured in joules. So I need to decide which of those three that number is. The problem says of energy, so I know it's one of the two types of energy and not work. To decide which type, I have to look at what else am I dealing with in this problem. Since I'm looking for speed, that means that this baseball's in motion. And if something's in motion, it has kinetic energy. So that means that that 162.9 must be the kinetic energy. So I'm going to use Ke. Now I'm going to now I have to pick which formula to use. I need one that has V, M, and Ke in it, which is going to be this third one down. So imagine covering up the V squared in that formula to get that V squared equals Ke over 1/2 M. Now I'm ready to plug in numbers. So I plug in 162.9 joules divided by 1/2 times 0.145 kilograms. You need to be very careful about how you plug that bottom part of the formula into your calculator. One option is to put all of that into parentheses. The other option is to put 1/2 times 0.145 into your calculator and make a note of what that number is. In this case, 0.0725. And then you can do that 162.9 divided by that number, which will get you 2246.9 meters squared per second squared. Now this is equal to the speed squared, so I'm going to have to take the square root of that number. And once I take the square root of that, that gets me 47.4 meters per second, which is my answer.